A rocket takes off with the thrust of dozens of engines, and 7 minutes later, it returns to the exact tower it took off from, but not the whole rocket, and not while it's tumbling out of control, because what SpaceX caught was the Super Heavy booster, a roughly 230-foot class first stage that flies itself back, slows down in midair, and slides into two mechanical arms with almost no room for error. The answer is not one trick, but a chain of decisions that all have to go right, including the trajectory, the engine burns, the guidance system, the tower, and maybe most importantly, the decision to abort if anything looks wrong. Because by the end of this, you'll see why the giant metal arms are almost the easiest part. When people say SpaceX catches Starship, they usually mean the Super Heavy booster, which is the giant first stage at the bottom of the vehicle, the part with 33 Raptor engines that gets the full stack off the pad. But once the upper stage, called Starship, separates and heads off to space, Super Heavy has a completely different job. It is no longer going up, it is going home. And on Flight 5 in October 2024, SpaceX did something it had never done before. It returned that booster to Starbase in South Texas and caught it with the launch tower on the first try. Meanwhile, the Starship upper stage continued to fly its own planned trajectory and eventually splashed down in the Indian Ocean. So the catch people are talking about isn't the entire rocket being plucked from the sky. It is the first stage returning to the tower it launched from. And the first seemingly impossible part happens almost immediately after stage separation. At this point, the booster is still flying away from the launch site. So to return, it has to flip itself around and fire its engines in what's called a boostback burn. Think of throwing a ball forward and then asking the ball to fire a rocket engine so it can come back toward your hand. That is basically the problem. The boostback burn shifts the booster's trajectory so it can head back toward the coast and toward the same launch tower it cleared minutes earlier. But getting back to the launch site is only the first problem. Targeting a general area from high altitude is one thing. Arriving beside a narrow tower upright at the right speed at the right angle is something else entirely. And this is where you might ask the obvious question, why not just land it like Falcon 9? Because Falcon 9 has landing legs, it can land on a landing pad or an autonomous drone ship. That system works. But Super Heavy is huge, and SpaceX's idea is to take some of the landing hardware off the rocket and onto the ground. Instead of having to fly heavy landing legs all the way up and all the way back down, the booster is designed to be supported by the tower's arms. That is the promise. Less hardware flying with the rocket, less recovery work after it comes back, and a booster that comes back directly to where it might one day be prepared for launch again. But that trade brings a brutal new requirement. The rocket has to hit the tower exactly where the tower expects it to, not nearby, not close enough exactly, because on the way back down, Super Heavy is still going fast. So before it gets to the tower, it has to have its engines reignite. For a landing burn, that burn has to remove speed, but it also has to preserve control. This is where the catch stops looking like a stunt and starts looking like a guidance problem. The booster has to control position, altitude, orientation, and velocity while its engines are firing and the ground is getting closer every second. It has to arrive vertical, it has to arrive beside the tower, and it has to arrive slowly enough for the arms to take the load. The goal is a tiny little capture zone attached to one of the most critical pieces of infrastructure that SpaceX has. And here's the part that people have backwards. The tower arms are not lassoing a falling rocket through the sky. They are not rescuing a missed landing. The booster does most of the hard work before the arms ever even matter. It steers itself into position during a controlled, powered descent. Then, once it is in place, the arms wrap around the booster at its designated support points. The arms complete the capture. They don't create the landing. The distinction is important because it explains why the catch can only occur after a long chain of successful maneuvers. In a typical landing system, the ground is largely passive. The rocket brings its own legs. It touches down. The pad is only the destination. But with Super Heavy, the tower is actually a part of the recovery system. It has to be ready. Its arms have to be in the right configuration. Its systems have to be healthy. And everything has to come together at the exact moment the booster arrives. So the catch is not authorized by the rocket alone. SpaceX said Flight 5 required thousands of individual vehicle and pad criteria to be met before the catch attempt could proceed. So this isn't just one machine landing next to another machine, it is two machines making a simultaneous decision in real time. And that is why the catch is more than a precision flex. The booster is coming at the same tower that SpaceX is going to need for future launches. If something is wrong, forcing a catch would be a very bad idea, so the system needs an out. For Flight 5, if the required conditions weren't met, the booster was supposed to deviate from the tower return trajectory and proceed with a Gulf of Mexico splashdown instead. That is the safety logic. No green light from the vehicle, no catch, no green light from the tower, no catch, no confidence in the return, no catch. The thrilling conclusion only occurs after the mundane checks say it is okay, and on Flight 5, everything was green. The whole sequence from launch to booster catch was about 7 minutes. Launch, stage separation, boostback burn, back to starbase, final braking. Then the booster just dropped down beside the tower as the arms closed around it. At this point, the engines were shut down and the booster was no longer standing on legs. It was hanging from the tower. That's why the footage is so strange. Your brain expects a rocket to do one of three things: explode, splash into the ocean, or land on the ground. Instead, this one stops next to a skyscraper-sized structure and gets picked up. But this is not just about making rocket landings look more cool. The goal is to make rockets less disposable. A traditional booster recovery could still require transport, handling, inspection, and repositioning before launch again. A tower catch is meant to return the booster right back to the location in which it could eventually be inspected, serviced, stacked, and launched again. But eventually is the word that matters. A catch proves that capture is possible. It does not prove that a rapid turnaround is routine. It does not prove that the booster is ready to fly again the next day. And it does not prove the entire Starship system is reusable. Because the upper stage is a different problem, Super Heavy recovers from the lower part of the flight. Starship, the upper stage, has to survive a far more violent re-entry before it can ever be recovered and reused reliably, and Starship testing is still a development program. There have been great successes, there have been serious failures. Later flights showed that SpaceX can succeed with a booster catch while still having problems with the upper stage, and the regulators can also require investigations to occur after mishaps before they'll allow launches to resume. So the tower catch is not the finish line. It is one solved problem within a much larger system that still has to demonstrate its reliability, its safety, its repeatability. So how does SpaceX catch a rocket in mid-air? It doesn't just reach up and grab a falling booster. The booster reverses course. It then guides itself home, and then it brakes to the side of the tower. And only when both rocket and tower pass a very strict checklist do the arms close. The catch is the last second. The engineering is everything that happens before that. And if you want the next breakdown, the bigger question is this: how do you catch the upper stage after re-entry?